Okay, so let's move on to our third topic, Paul. This is the big one. It certainly was a big outage.
Oh, so. Yeah, definitely.
Okay, so it's the AWS outage. What the F happened? Now, the funny thing is, not to be outclassed, Microsoft Azure decided to fall over a week later.
Yep.
And then a week later after that, it was Cloudflare's turn.
Yep.
Yeah, so I think everybody wanted to join the AWS outage party. So maybe we should use that in the future, have an outage party kind of award or something for that. But yeah, give me your kind of take on what was sort of what you observed from it, and then I'll come in with some interesting influencer reports and posts.
I mean, the thing that surprised me, I think probably start with what surprised me, was that it affected as many services and applications globally from one region, i.e. the Northeast, in Virginia.
Yeah.
And that was a surprise until you started to get into the detail of how the whole thing is put together. And so, you're looking at where the problem first arose in the sort of DNS tables, and the way in which they interact with DynamoDB, to get the updates, etc. And whatever happened, whatever registry problem that they seem to have got at that point had such a knock-on effect. So it was the knock-on effect for me that was the most interesting and probably the most consequential for people to think about, because it took out EC2 instances. It basically took out, large swathes of DynamoDB capability. And I think the thing that I sort of took from it was that more customers than we have ever realized have potentially got single points of failure. Even if they think they've maybe got different availability zones within one region, it wasn't going to protect them. But even across regions, that was the interesting thing. It says, right, how do you stop that happening? And again, if you want an analogy, from what happened, and we can sort of read out exactly, what happened at between the DNS servers and the load balancers,
which I will go into, a little bit more. We'll go into that.
If you want to give a sort of real world example of what it looks like, and I was going to use the motorways, but it's probably more like if there's a dirty great big pile up in the middle of London, or they dig the roads up in the middle of London, what happens? All the traffic starts to back up. People then try and find other ways around it and mess up all the other routes as well. And you could see this sort of thing happen, almost like if you were sort of hovering above AWS, Virginia plant, you could almost see these little sort of transactions all going, oh, I can't get through that one. I'm going to try that one over there, and I'm going to try that one. And so what people have not realized is that there are some choke points, and they just need to be aware of what those choke points are. And I know, from our conversations, that these will happen.
Yes.
These problems will happen. It's a very complex arena and very fast moving, and therefore these will happen. So then we'll come back to, what are the implications for businesses?
Yeah, well, I mean, obviously, there was certainly, I think, aspects of that caused, as you said, a lot of disruption. Now, whenever these things happen, as it was with the CrowdStrike outage last year, we tend to find out who the customers are, right? It's like a customer list. If anybody else, a competitor, wants to know who's who and who's using, CrowdStrike as it was last year and AWS this year, now we know who's using them because they're all out. And the funny thing was, some of the banking services in Europe were knocked out. That was really surprising. So that was strange. So, sovereignty ahoy, what's going on there?
Yeah, and there's a sort of question that's not been asked is, how did you architect this in the first place?
Why are you going out all that way?
Why are you going out all that way? Now, if you go to the earlier days of AWS, they, more than Microsoft and Google, tended to route traffic back into the States and round again.
Yeah.
But they got over that because it was actually creating some level of latency that the other two weren't getting. So, and particularly if you'd looked at the way, Thousand Eyes can show you where all the routings happen.
Yeah.
And that was really interesting to see. And you're thinking, well, are these applications that were architected when that sort of routing went on and just haven't been updated?
Since, yeah.
I don't know.
I don't know either. The interesting one was the hanging by a piece of string point for me was that the fact that AWS's own services went down.
Yeah.
So their service, which got not necessarily connected to what customers are doing, also went down.
Yeah.
So you had kind of the lambdas and whatever also failing. And I'm thinking, isn't your services on a kind of a back-end bus or something, running on a different bus than what you would present to customers? Isn't it architected in that way? That's a very strange way to, so
they're just using,
they're using the same service as everybody else.
It looks like it, and using certain, things. It seems to be the load balancers were the ones that got into trouble first.
Yes.
So whether they, yes, they thought they got all the back end, the application was away from what they were doing. But if there was a sort of network requirement or a load balancing requirement, it seemed to be going through that route. Where are the single points of failure? And I think you've always got to think. Are there going to be these single points of failure? Back to arguments we've had about, how expensive it is to completely, duplicate everything you're doing.
Yeah.
And maybe it's, the implication for businesses is think, you cannot outsource your response, if you like, the overall governance and responsibility for what you're doing in the cloud. But it does feel sometimes like they have.
Yeah, I mean, I'm just flabbergasted by the fact that their own services went down as well.
Yeah.
I mean, I would have thought customers can't get to that service, but not that service going down. Do you see what I mean? There's a subtle difference there between, my service has gone, my app has gone down, my business app has gone down because yes, they've screwed up our DNS, and there's nothing I can do in my own cloud environment, in my world in AWS, because it's happening higher up than me. So I've got no control over it. My DNS is fine, and within my environment it's fine, but I need to go to the outside world, and then that's gone down. That's what AWS has caused. So that was what I would expect. So you go down from a customer side of things, but not the AWS service necessarily.
But this is where you were getting issues where people had thought about it and saying, well, I need to architect this, that if this particular DNS service gets into trouble, then I could switch to another one. And if you look at the report that came out of AWS, you could see that happening. But then, of course, they got latency issues, and as they tried to move across and replicate into because they had to take the tables and replicate them across into another one. You think, would you mirror those tables, for example? Maybe they hadn't done that, but again, you come back to this issue that says it's a very complex environment that you're putting together. Do you, Mr. Customer, understand exactly how you've architected that and where your risks lie? And that's the implication coming out. Because you and I have had this conversation that says, problems will happen. I was going to use another term, but problems will happen all the time because it's, human problems, just systems failing for whatever reason.
Yeah, and we've, like I said, I think we've said this before, we've embraced failure. We understand that systems in a cloud environment will fail. So we architect, around that or against that, right? It's trying to avoid that and mitigate the risks as much as we can. Whether it's, introducing things like, chaos engineering, for example, into your code so that you can actually make your, systems and applications resilient. But then the environment itself, the cloud environment, you have a high availability. And that high availability as an enterprise, so you're not going to copy everything across. You're going to have a replica in another region just twiddling its thumbs, just waiting for things to fail in your primary region. But you can potentially, using extremely sort of high and cloud native services and capabilities, you can stand up an environment using serverless, for example, and other things that will, not 100% of the service back online, but it'll kind of give you something that will allow you to mitigate, and you can continue your service and taking your orders or whatever it is that your business is doing.
They're interesting. You say you can mitigate it and take your orders, and maybe it's not moving as fast. Certain, obviously, environments, financial trading for one, couldn't deal with that. Would have to have it almost completely mirrored and just fail over completely. And then if you go back, in my past and even before your past, I think, you go back to the OLTP systems from the IBMs and Unisys of this world.
Yeah.
They mirrored their systems, and it was, you had, this sort of embrace that they had, got it the sense that the minute your system went down, the mirrored system picked up exactly where it left off.
Yeah.
And I've seen that demonstrated. So I've never understood in a cloud world how you do that, or whether you can do that quite in the same way without it being very complex and very expensive.
So people tend to do it, and I think this was, again, obviously a failure, because this was a fundamental kind of root failure of that entire region, right? They do it in availability zones. They do it at the AZ level.
Yeah.
But the AZ is in the same region.
Exactly.
So that's no good.
Yeah.
But that allows them to be quick on the replication of the data, for example.
Yeah.
So rather than going outside and through the Atlantic trunk and whatever and getting over there to another region and doing your data back up there, they do it in another availability zone. The problem is, it's like a pyramid. At the top is the DNS, and that's at least that's one of the things, and that's what's caused the problem.
Yeah.
In this case.
Yeah.
And there's nothing you can do about it at the bottom of the triangle. Of the pyramid, there's nothing you can do about it there. You can be as resilient as you like, you can put all your stuff in another availability zone, but the problem is going to be that at the top of that pyramid is a service that you've got no control over. And if that falls over, which it obviously did, the whole thing is gone.
Yeah.
You can be in 10 availability zones in the same region, but it's not going to help you.
So you need it in another region.
Exactly.
You need it in another region.
But then that's the joke that I made on one of the LinkedIn posts, that we said that the CTO and CIO tell the CEO how much it's going to cost. The CEO goes to the CFO, and the CFO says, forget it, because it's just so expensive.
Yeah. Again, and this is for another time, is it ought to be the other way around. They ought to know already that this particular system A is so mission critical that it'll kill our business if we don't do this, and therefore the cost is almost irrelevant. Almost. But it's risk management,
right?
And
and how many people do that risk assessment?
I've been a non-exec director, and I can say in certain areas, particularly public sector, I don't think they do it very well at all.
Yeah. So just for the record, I actually did a talk with Saim Saftar on his Cloud Native FM YouTube channel on the actual sort of the technical aspect of the failure. So I'll drop the link in the description for you guys to have a look at that. But just to cover the kind of the technical aspect, so we'll kind of AWS did a kind of a copy and paste of this massive one paragraph. I think probably trying to hide and bore people to death with this massive paragraph, all these internal names of the services and scripts that they run to update and propagate their DNS tables. But essentially what's happened, and I'll come back to another point on that, but essentially what happened was the first enactor, as they call it, which updates the DNS tables, took longer than usual to complete its updates. By that point, enactor 2 comes in and updates the tables. It just looks at what it's got and is going to say, okay, that's all old. I'm going to delete all of that. And it removes all of that. Enactor 1 is still running. So enactor 1 comes back in and is now finished, or is picks up from the delay. And then it looks at the enactor 2 table, which is more up to date than its own. there's no check in there to see whether its own data is now stale because of Enactor 2 having updated it, and just goes, oh, that's old stuff and I'm going to get rid of it. And then gets rid of the new tables, the new information, and brings in the stale data from Enactor 1 from its own update. And that's what really killed it. And at that point, obviously, that caused all the services going down. We won't probably go into all the kind of who got what and got kicked in the teeth and so on in regards to that. But as you said, the list is long and distinguished.
You just wonder how many instances of that DynamoDB, the Dynamo database, were and where they were placed, because it felt like it might have been that particular DNS
Enactor
that was causing the problem, and yet it created a much bigger issue than you would have thought. In taking down, firstly, because it affected a lot of other DynamoDB services that probably weren't directly affected by the first failure.
Which is what I'm saying to you. Why is AWS running their own kind of back end, what I would call a kind of a trunk back-end system, back-end architecture, back-end bus, whatever you want to call it? Why are they running it on the public version that they offer to their customers? So their traffic is what? Going through the same network as the customer traffic for their own back-end services?
It's a good question to ask.
I know. And the point I made about the first Enactor delaying, they still haven't explained why it was delayed. Because they said because of some unusual delays or latency, whatever they threw into that massive paragraph.
They called it a latent problem.
Yeah, but they didn't explain why.
Why? No, exactly. There was no what happened there.
So the RCA for that, the root cause for that, we still don't know. That's not public, as far as I know.
Was there a software or a configuration change that caused that problem? You don't know, and that's the issue with. If
anybody knows, by the way, drop it in the comments.
We'd love to know.
Yeah.
But I think the challenge will always be that there are that many potential areas where things can go wrong.
Correct.
That you have to plan your systems architecture and your response to those in that sort of light. And I just get this sort of sense every now and again that too many people in organizations, enterprise organizations, are thinking it's almost like outsourcing. I've outsourced it. It's on the cloud. It's fine, and it's not.
The cloud never goes down.
The cloud never goes down. Yeah, absolutely. And we've always made the point when I was at Bloor, trying to say to them, it's not a fluffy thing, the cloud. It lands on servers and switches and storage devices wherever, at some point. Stop thinking it's something that is complete, it's almost if it was a cloud, there would be so many multiple interconnection points that there would be no points of failure. There are points of failure.
Yeah, I remember, I think I've quoted this to you before. I think it's like decades ago now, so I can't even remember who it was. I think it was either the CTO or the CEO of Hitachi Data Systems. And I remember one line that he said, and that line is said, the damn thing's got to run on some hardware at some point.
Yeah. Yeah.
And that's always stayed with me, because I was like, no matter how much you have in your software stack, the damn thing's got to run on something.
Yeah, I mean, when Mark Andreesen did his, bit back in 2011 about software eating the world, people did start to get to that point that, you're having to say to them, we still need the hardware.
Yeah. Yeah, you still need that in there, right?
Still need it. It
Absolutely.
might now be, much more of a, basic level, but we still need it.
Yeah. So, like I said, I've done a Cloud Native Wisdom episode with Saim on his Cloud Native FM channel, so I'll drop that in the description for you. Now, I just kind of want to move on to the LinkedIn influencers a little bit, Paul. I think we've done the enterprise, we've done everything else. Let's kind of just cover off a little bit there. So the first of the culprits was Guy Massey. I can't remember who he is. It's probably on LinkedIn somewhere. I'll drop the links in the description for you guys. But he put out a post, and he was talking about what did he say? He said it was an internal DNS resolution issue surfaced. That's what happened. So again, it didn't really kind of talk a little bit, too much about sort of the details of what the problem is. And immediately, I think that particular post from him went on to talking about, resilience, and you're going to have resilience. And I told you so. You must have resilience in your systems. He did point, I have to say, so I'll give a little bit of credit. He did point to another report, I think, from himself, as he's quoting himself. And he said, I think in that one, he was talking a lot more about the previous event that had happened again in Virginia. And he was warning about the
potential
East Region one again having a problem. So he did. I think he kind of probably got it right, but just the response he put in this one was the usual. It was DNS, and then you must have some kind of resilience. But that's not an answer to anything.
Well, in fact, it's a dangerous answer, because resilience and high availability are not the same thing.
Exactly, as we've
discussed a number of times. So, and that's the difference. I mean, you could say, is a proper IT architect or a CTO like yourself ever going to take that at face value? But the trouble is that if you get business people looking at it who are not technically oriented and going, oh, we need to make it more resilient, and then the CTO says, but it needs to be high availability, and they go, and you get into that. Well, it costs too much, and I think it's dangerous when we don't describe those particular differences, well. What's the difference between resilience and high availability?
Yes,
you can have a single system that's very resilient until it fails.
Exactly, and I think again there was other reports. So we'll come to, I think, David Linthicum's in a minute, so we'll just mention that briefly. And I see you smiling there. But there was also a lot of conflation. And this happened last year, and we commented on it when somebody blamed just generally public cloud for the outage that we had from CrowdStrike last year, which is completely disconnected from each other. They've got nothing to do with each other. And again, there was conflation, I think, in some of the reporting there. And I did point that out to Guy in a response to the post or a comment that I put in his post, but I didn't get a response from him on that. Some people liked it. They said kind of, because I was saying, I assume you got kind of full proof in terms of these two things being connected, and he didn't respond to that. But other people seem to like the comment that I made. So the other one, again, I think I get this all the time from these sort of LinkedIn influencers and Shills and what have you, all putting out all these things saying, I told you so, or we warned you last year, or I said this 18 months ago, or 10,000 years ago, whatever it was, kind of thing. So again, David Linthicum put out a couple of posts, and again, it was the wrong terminology. It was all about resilience. You must make your systems resilient to be risk averse and blah, blah, blah. And again, I just think that was not helpful. Those were not explanatory enough. They didn't go into the detail. They didn't give you a way out. How do you get out of this mess? How do we, architect around this? And the wrong. I was just cringing at the terminology, I have to say.
Yeah, and it can be dangerous in the sense that you will get a false sense of security for companies or enterprises who suddenly say, "Oh, my systems are resilient." Yeah, they may be, but that still, when you get this sort of situation, if you need high availability, you need to pay for it high availability. You can't just make your individual systems more resilient. And so it's too easy to do on the internet generally, in social media generally, is to use a term without really thinking about it. But I do think that the use of the term resilience as opposed to high availability, particularly in this AWS case, is going to lead people down the wrong path. They're going to spend money making their systems more resilient and still get hit by the same problem.
Yeah, and I mean, I just think people should not be kind of, jumping onto the bandwagon so quickly. And I think they need to be a little bit more measured, use the right terminology is kind of the bugbear really for me. And as we said, we try to kind of go by the book as much as we can, and we use the correct terminology when we can. God knows we're not always right, but we do try and do our homework and not use words like resilience, for example, as in this case. Because as we said, if you just make it resilience, not going to work. Put it in another availability zone, it's still not going to work.
Yeah. I mean, I can make a resilient server, and I can take I can take a hammer to it, and it doesn't react. It's very resilient.
Yeah, it's very resilient. Exactly.
If the DNS goes down in Virginia, stuffed.
Yes, exactly.
So because you had no high availability. No,
Indeed.
We can also question how many people take the influencers seriously.
True.
But I don't know. I mean, it could be dangerous.
It could be. Absolutely. Absolutely. Okay. So I will drop the link for the AWS description, that big, massive paragraph page that they try to hide all the details in as well. So that will be in the description of the video as well. Thank you for watching. Please don't forget to subscribe to the channel to support me. You may also want to check out some of the other videos on this channel. Bye for now.